Hey guys, in this lesson we would understand what is the equation of an altitude and how to determine the equation of an altitude when you're given a triangle with vertices. First of all, let's understand what is an altitude. Let's say we are given a triangle. The simple name of altitude is height. So altitude is a line that is drawn from a vertex to the opposite side of the triangle. Because it is height, it is supposed to be drawn at an angle of 90 degrees. So if we have a triangle ABC and we have to draw an altitude from A, then we have to make this line go and hit the opposite side of the vertex. Wherever it meets the opposite side, it meets it at an angle of 90 degrees. If we mark this as a point D, then AD can be called the altitude of triangle ABC at side BC. Always remember that the altitude has to meet the opposite side of the vertex from where it is drawn at an angle of 90 degrees. However, it need not cut the opposite side into two equal halves. For example, if we want to draw altitude from R to side PQ, we need to make sure that the line that starts from R meets the side PQ at an angle of 90 degrees. However, if we mark it as S, PS side is not supposed to be equal to SQ side. And we can see that this side PS is smaller than this side SQ. The only requirement for an altitude is to fall at an angle of 90 degrees to the opposite side. That is it. Now, if we are asked to write down the equation of RS, let's understand how to determine the equation of an altitude using this example. So we are supposed to determine the equation of the altitude RS, that is this altitude. We are given points P, Q, and R. We can put the coordinates of the points here itself. So point P coordinate is -3, 5, point Q coordinate is 4, 3, and point R coordinate is 1 and -4. Our first job is to make the triangle and mark the coordinates, because here the triangle is already made. So the first step is going to be to determine what type of equation we are looking for. Now, since we are looking for the equation of a line segment, and that is line segment RS, the best way of writing equation is y equal to mx plus b form. So we need y equal to mx plus b form of line equation for line RS. Now, for whatever line we are looking for the equation, we need the slope of the line and we always need the y-intercept of that line. So we need the slope of line RS and we need the y-intercept of line RS. Once we get these two, we would substitute that as m and b, and then we can write our equation for this line. Now let's understand the steps of getting slope and the y-intercept of this line RS, which is also called the altitude of this triangle from R to PQ. Now, one thing to remember here is that whenever we need to find the slope of a line, we need 2 points on the line. We know point R, however, we do not know point S. And in this particular scenario, we cannot find out the midpoint of PQ to get the coordinates of S, because S is not in the middle of PQ, as it was in the previous lesson where S was meeting the midpoint of the opposite side PQ, because RS was the median in that case. And the definition of an altitude is not to divide the opposite side into 2 parts. It's just to fall on the opposite side at an angle of 90 degrees. Therefore, in order to determine the equation of RS altitude, the step 1 is find the slope of side PQ. Now, what is the reason we are looking for the slope of PQ? So, because PQ is perpendicular to RS. And when two lines are perpendicular, their slope will always be negative reciprocal of each other. So once we know the slope of PQ, we can then negatively reciprocate it to get the slope of RS. So we need not use point S to find out the slope. So to find out slope PQ, we would do y2 minus y1 over x2 minus x1. y2 is 3, y1 is 5, so it's 3 minus 5. x2 is 4, x1 is negative 3. Therefore, the slope that we get here is minus 2 over 4 plus 3 is 7. That is negative 2 over 7. So the slope of the side PQ that we have found is negative 2 over 7. But we did not need the slope of PQ. We wanted the slope of RS. We would use the slope of PQ. So from the slope of PQ, we would get the slope of RS by negatively reciprocating it. Negative reciprocal means we flip the given fraction and we flip the sign. This is already a negative sign. So if slope of PQ is negative 2 over 7, slope of RS would be flipping of numerator and denominator here and flipping of this sign. So this becomes a positive 7 over 2. From the step 1, we have found the slope of RS that is equal to 7 over 2. Therefore, we can modify the step 1 by saying find the slope of side PQ and negatively reciprocate it. Now, since we have got the slope of RS that is 7 over 2, we are left with finding the y-intercept of RS. Let's call it step number 2. And how do we find out the y-intercept? We know the equation we are looking for is y equal to mx plus b. This equation that we are looking for is for RS line segment. M of RS is 7 over 2. We are looking for B of RS. So we would substitute M as 7 over 2. In order to find out the value of B, we need to substitute X and Y as a point that lies on this line segment RS. And we notice here that the point that lies on this line segment RS is just one point known to us, and that is point R. The coordinates of point R are given to us as 1, negative 4. So point R is 1, negative 4. We can use X and Y of point R to substitute in this equation, and we can solve for B. So we would move this on the other side. We get negative 4 minus 7 over 2 equal to B. We can make the denominators common by multiplying and divide by 2. We get negative 8 over 2 minus 7 over 2 is equal to B. Therefore, finally, we have the B value as negative 15 over 2. So we got the B of RS as negative 15 over 2. Now, as we've got both slope and the y-intercept for the line that we're looking to write on the equation for, we can write our final step, and that is to write the equation of the altitude. Y is equal to mx plus b, where m is 7 over 2. And B that we just found out is negative 15 over 2. Finally, we are left with y equal to 7 over 2 x minus 15 over 2. And this is how we write the equation of an altitude given the vertices of a triangle.